Good day, ladies and gentlemen, and we are getting very, very close to the end of this exam paper. Okay, this question is specifically about Venn diagrams, probabilities, and some beautiful intermingling of concepts that we work with. So, this is Mr. VG, and it's an absolute honor to have you join me in this video. When we look at Venn diagrams, remember, Venn diagrams is all about when one person has got different options to choose from. Or sometimes they could choose more than one options or even more than two options. So for instance, someone could take where am I going with this? Someone can, for instance, take maths and science and life sciences, if we look at different subjects. So when we talk about this, a Venn diagram question typically looks something like this. In this case, this was question 7 in this exam. I want you to go and try and do this sum yourself before we look at the rest of the video. So hit the pause button and then we continue going forward. So when we look at this, the first question that we look at is, let's interpret the scenario. So they've got 3 options to choose from: netball, basketball, and chess. So there's my 3 options. There were 80 students in total. That is a very important thing. That means everything in your Venn diagram must add up to 80. Don't forget that little line above the A part, which says that there were 15 students in total that played netball. So if I look at question A, it says complete the Venn diagram. So let's draw in the netball. So that whole circle must add up to 15. Very important. So that means that little bit of an empty space must be 5. Now, where can we go further? Don't forget, we also have there are 80 students. So I love if there's an open space on my diagram, I'm going to put it as X. Okay? I love to do this personally because I'm a mathematician. But you can put a block there if you want to, or draw a picture, but I would just use X, okay? So if I look at this, the 5 plus the 10 plus the X plus the 30 plus the 15 must add up to 80 because there are 80 students in the whole sample space, which then means that X plus 60 must be 80. So logic tells me that X must be 20. Before you go on to the rest, let's put it in on the sketch. X must be 20. Now, ladies and gentlemen, I just want to quickly hit the pause button and just quickly go back a little bit, okay? That means that 20 is the number of kids that played only chess. And that 5 is the kids that played only netball. The 10 is the kids that played netball and chess. So how many kids, and this is just a nice little question for me, how many kids played chess? I'm not saying only played chess. Well, 30 of them. And again, you'll see my terminology, N of. That means number of, not probability of, not P of. N of means number of. Okay. Hope you've got that. Okay, so let's carry on. The B part says, calculate the probability that a student chosen at random did 2 sports this year. So in other words, that is where two circles overlap. Okay, because they say 2, so it's playing netball and chess. This means I can write it like that. Now look at my term, at the way I write it. P of. That means probability of. So the chance of. And that is 10, because there's 10 in the overlapping, over 80. Why 80? Because we looked at 80 kids in total. Okay? The next question is, the number of kids that did B, basketball, and chess. Now here's something important. And remember, so let's start with N means number of, so that I answer the right question. And the word and means overlap in Venn diagram specifically. Now, does the basketball and chess circles overlap? No. That means there are no kids that's lying inside basketball, in other words, that played basketball and played chess. Okay? So in other words, the N of B and C is 0. So the probability of a kid playing basketball and chess in this scenario is 0. Okay? So there are no kids that did those two sports together. The same with netball and basketball. Okay? Now we ask you an interesting question. Using your answer in C, so in other words, that answer of N of B and C being naught, there's my keyword. The overlapping is 0. The events of playing basketball and chess are mutually exclusive events. Okay? Why do we say that? Because mutually exclusive means things that cannot happen at the same time. So someone cannot play basketball and chess at the same time. Not in this case, at least. Okay? Let's look at the next question. If this survey represents the preference of all the students in the upper school, so in other words, in the high school, which 464 students, so now the total number of students in the high school was 464 students. Calculate how many would play only one sport. So I want to actually know what was the probability in this sample space. Remember, sample space, ladies and gents, means I've looked at the whole population and I only took a sample of kids, so a number of kids to do my experiment on. But now we need to look at the whole population. And an important thing was that the survey represents. So in other words, it is a good description of what actually happens in the whole school. There's a big important concept there. If they didn't say that, we couldn't actually answer this question. If it didn't represent the whole school, then we wouldn't know how to compare our sample space with what we would call the population of the school. But it does. So let's look at my Venn diagram and look for the probability of doing only one sport. There's the 5, the 20, and the 30. And this is, in this case, over 80, because that would tell me that 55 out of the 80 students did only one sport, which gives me about 68.75% of the kids did only one sport. But that is for the sample space. Now, that means that 68.75% of this whole school would also only do one sport. Why? Because I tell you it represents it. So I'm going to take the 68.75 and I'm going to percent and times that by the 464, because there's a 68.75% chance that a kid would do only one sport. So that means 319 kids did only one sport in the school. Interesting, right? Yeah. Look, there are different ways, and I expect you to also find maybe different ways that makes sense to you as well. Okay? I'm thinking about it in this way. Maybe you can think about it in another way, ladies and gentlemen. There's so many different ways of doing maths, and I would love you to find a way that works for you. So this is Mr. VG signing out. Please tune in to our last video on paper 1 preparation, which will be about my favorite graph, which is parabolas. Parabolas, I love that. In our next video, we'll do a beautiful application of parabolas as asked in an exam. So keep well. Cheers.